Welcome to the Infill Podcast, where we interview the most interesting members of the 3D printing and maker communities, live and with audience participation. And now, here is your host, Jonathan Levy.
Greetings, everyone. Welcome. I'm so excited for today's episode. We're going to get to our guest and his story in just a moment. But first, one of my favorite sections of the podcast, which is What's Printing, Jonathan, brought to you by Octo Everywhere, the section where I show you guys all the spoilers for all the projects I have coming up in the coming weeks. Thanks to Octo Everywhere, because all my printers that are currently running are at the studio. You can see Python is printing some fun little pastel cupcake things. Greyhound failed, and I just realized that I turned off the filament sensor on Millipede, so it didn't trigger Octo Everywhere's built-in AI failure detection, and you can see clearly my filament spool got stuck. So remotely, I can pause the print, cancel the print, even though it's a couple kilometers away from here, and save many, many hours. Check out link in the description for Octo Everywhere. You can get a $25 free credit, which goes a long way towards getting your printers monitored. On to today's guest. Today we are joined by Too Tall Toby. He is a former SolidWorks expert and professional, having solved over 10,000 tech support queries for SolidWorks. He is the host of the World Championships of 3D CAD, and he's a content creator who believes that CAD can be fun and engaging. Toby, welcome, my friend. How did I do? Pretty good, right?
All right. Thank you so much. That was a great intro.
Thank you,
Great to
sir.
see you. Yeah, great to see you. Great to see everybody in the chat. And thanks so much for having me on the show today, man. This is awesome.
It is my pleasure. As I said, consume your content. I feel like your content is very much like my gym membership, and that I wish that I did more of it, because I really aspire to get better at CAD, and I find it very refreshing the way that you're teaching CAD, as opposed to, because as we were talking about before we hit record, my background is in learning and helping people kind of learn faster. And one of the best ways to learn faster, if not the best way, is learn by doing, rather than this is a spline. And I try to remember next time I need to do a spline. But I want to ask about your journey, because you didn't start out as a CAD professional. You started out in sheet metal fabrication. Tell me about this this arc.
Yeah, I mean, that's the arc. But the first job that I had was doing sheet metal progressive die design. So designing sheet metal, you can either handle sheet metal, usually you handle it in a few different ways, but one way that you can handle it is that you could just physically hand bend it. So you do one bend at a time, or you could design up a die, which is going to be like a series of stations. And then what happens is the sheet metal gets fed in off of this giant roll, and it gets it's really interesting. It gets flattened over the course of like 100 meters, and it kind of so it comes off the roll, and then it has this big long trough that it can flatten out through, and then it goes into this progressive die station where each station, the press comes down and hits it, and then it moves forward a station, then it hits it again, moves forward a station, hits it again. And so you have to design a die that represents each of those bends in the sheet metal process. And then when the thing comes out the other end, the final station punches all the remaining tabs, and then the sheet metal part drops off. And so this machine would just run all day. It's like a 200-ton press, 400-ton press, and it just sits there and it runs all day like juice, juice, juice. And each time it's hitting it, it indexes one station forward, does the next bend, indexes one station forward, does the next bend, does the next bend. And so when it's all said and done, you have this final sheet metal part that drops off into the tray. And then at the end of the day, you have a couple hundred or a couple thousand of these brackets, and then you can sell them to the customer. So started out in that area and started out really designing those progressive dies using 2D at first, using 2D AutoCAD at first, and then moving on to 3D and designing them all in 3D, which was, a huge shift.
So that's a great question, because I always, and this is like my coping mechanism, when I see guys and gals like you, or I watch other content creators like Jan Schoen from Proper Printing or Morley Kurt, I always try to comfort myself by figuring out where they learned CAD. And then most of the time I can go, oh, okay, they went to engineering school, they went to trade school. I feel better about my CAD skills. Where did you learn CAD, 2D and then 3D? Did you get a proper education?
Semi-proper education, went to trade school, got into a co-op program, started doing these co-op jobs, where I would go out to a company and work with that company to kind of learn what their facility manufactured. And
Mm-hmm.
so a little bit of plastic injection mold design, a little bit of prototype fixturing design, little bit of sheet metal design. In fact, at this company, which is a company I ultimately landed on and stayed with after school, that's what they did. They did sheet metal progressive die design, but they also did fixturing design. And so with fixturing design, what you would do is you would start out with a sheet of steel, and then on that sheet of steel, you would you would mount like Destaco clamps that can kind of clamp down and hold metal tubes together, and then that would become a welding station. So the
Got it.
people who were doing the welding would take a couple of tubes, they'd put them on this plate, they'd use these clamps to hold everything down, and then they would do the welding, and then they'd hand it off to the next person, or they would move on to the next station or whatever. And so that was a lot of in context assembly design, a lot of 3D design, designing those clamps. It was a lot of trying to automate the process of bringing those clamps in and having them create the stack of the blocks and punch the holes into that plate, because ultimately that initial plate of steel would need to have the correct holes physically manufactured, physically drilled into it, so that we could then mount these clamps on it, and that everything would end up in the correct position so that we could weld together whatever the device was, whether it was a frame or chair or whatever the ultimate device was.
Really cool. And it's so then you progress onward. I just want to get all the biography straight because it's so interesting to me. Like you're the only CAD creator I know, right? Who like specializes in CAD. So it's a very interesting journey to me. At some point you transition into actually helping people with SolidWorks. You experience 10,000 tickets of like seeing how people are struggling. And then I imagine that at some point in the journey you realize like, hey, the way people are learning CAD is not great, right? Or it's not fun, or like people are really not like people want obviously to be better at their job or their hobby or whatever it is, and it's not accessible, it's not effective. Like what was the aha moment where you go like someone actually needs to make this shit fun to learn?
Well, I think that the aha moment is really it kind of it's interesting the way that journey went. It actually kind of went a different way, which is something we were talking about before stream, which is what is the best CAD system out there? That's
Mm,
really where like all this is derived from. Is I was working in industry, and what happens in the CAD world, or at least what happened for a long time, is that there were what are called local resellers. So instead of purchasing directly from the OEM, like purchasing directly from SolidWorks or directly from Autodesk, you would often work with a local establishment that would offer training and would offer tech support. And that way, the people that you're purchasing from, you've actually met them in person, and it
right.
was, a much more personal experience. And then, of course, you could get training locally. And so I attended some of when I was still working in industry as a customer, I attended the resellers what's new presentations, where you would show up at a local hotel, a conference room in a hotel, and then they would show you like, hey, here's all the new stuff you get to use this year. And I would ask a lot of questions. And so eventually the reseller was like, hey, you're asking a lot of good questions. Maybe you should come work for us,
Oh,
And so
funny.
that's how I ended up in that space of now I'm the one doing that local training and doing that tech support. And during that time, while I was doing that tech support and getting those questions, the question would inevitably come in like, what's the best CAD system out there? What's the best CAD system out
Ah,
there? And so in my mind, right away, what I'm thinking is like competition. There's got to be a competition. We got to figure this out, And so
that's really
a lot of
cool.
times, yeah, a lot of times the way I would answer that question is like, I would say, it's not about the wand, it's about the wizard. It's
Yeah.
you take somebody who's really good at Autodesk, at Fusion 360, you take somebody who's really good at SolidWorks, and you put them up against one another, and you're going to probably have a pretty close competition.
That's really interesting. I also think of it, I have very little CAD experience compared to yourself, but I just think of it as like different brains. I mean, because of my background, I think about different brains work in different ways, right? Like there are so many people now raving about plasticity, and their whole thing is CAD for artists, right? It's like if you are maybe the type of person who's a little bit scared by numbers and figures and functions and program, and you consider yourself more an artistic person, and I think it's the same way, right? Like, I've been told by people who've used SolidWorks for decades, like, if you made that transition over from 2D modeling and you have a background in sketching and kind of design, you're just going to jump right into SolidWorks and feel so at home. Um,
Yeah, I think it's interesting. Like I've talked to people before who have said like they just don't have a 3D mind in the sense that, you know, if I look at something, a coffee mug, for example, right away I'm thinking to myself like, okay, you're going to revolve the main shape, you're going to sweep the handle, you're going to have to put fillets on the handle. Those fillets aren't going to be standard. They're probably going to be hold line fillets. Like I'm kind of immediately anything I see, I'm immediately unbuilding it into a set of features, and be stacked back up. But there's other people who really are more gifted in the realm of 2D. You know, they could look at something and they could just draw it up 2D. Like I can't sketch I can't sketch very well at all. Hand sketch, and sometimes people look at my hand sketches and they're like, how are you a 3D CAD expert? You can't even sketch like a cube.
Right.
But it's like, yeah, but I can put all the dimensions on it that I'm going to need to turn that into a 3D model so that when I 3D print it, it's going to fit perfectly into the car or, whatever the application is.
I had this moment like remembering the Born Identity where he's sitting at the cafe and he's like, I know, like, I don't know why I know, but I know that the best place to find a shotgun is going to be that truck right there. I know that that entrance is exactly 6 feet away. And that was that moment of you just being like, I know that those fillets are going to be whole line fillet.
Yeah, exactly.
I don't know how I know. I just
know how I know exactly.
so that's interesting that you were doing it as a reseller, so you were able to kind of be CAD agnostic and keep an open mind. Whereas if you had worked for SolidWorks or something like that, you maybe wouldn't have the opportunity to look at the greener grass on the other side.
I mean, it's always been very like fanatical.
Yeah.
I think that I definitely was skewed more towards SolidWorks during that period. And you definitely see that. I think people get very comfortable with the idea of being on a team. And so anytime they feel like they're on a team, even if it's something as, innocuous as like CAD,
Right.
they often will feel like they are on this team and that
Right.
they have to wave the flag of that team. And certainly
Yeah.
I've seen plenty of that over the years. And, I'm sure that I've succumbed to that as well myself over the years. But I definitely, when I would get those questions, I would want to know the answer. I would make the
Sure.
claim like, hey, it's probably not the wand as much as it is the wizard. But then I was like, well, I want to find this out for sure. And so that's
Sure.
why, that was a big reason why in 2020, 2021, 2022, like we really started heavily rolling out these CAD versus CAD tournaments.
Right.
And it really is like a world championship of 3D CAD. We have users from all over the world who try to qualify for these tournaments. And in the series of these tournaments, which we've had for a few years now, we've had a world champion using SolidWorks, we've had a world champion using Inventor, we've had a world champion using Onshape, and we've had a world champion using Fusion360. Shout out to Rambro's Workshop, who's actually in the chat right now. He's our current world champion of 3D CAD speed modeling, and he's a Fusion360 user.
No kidding.
Yeah.
I mean, once you wait an hour or so for Fusion to boot up. No, I'm just kidding. Totally teasing.
Yeah.
That's really interesting because I fully first off, I want to comment on what you said about tribalism, and yeah, it is a human thing. And who better knows that than us in the 3D printing community where people are so diehard about their manufacturer. But it ultimately comes down to people want to convince themselves that they made the right decision. And I'm the same way, right? Like you don't, once you've invested time, energy, effort, money, whatever it may be in learning something, you really don't want to feel like you went down the wrong path. And I had that when I first got in to 3D printing. I did some YouTube searching and what's the best design software for 3D printing. And I didn't know at the time there's a difference between organic modeling and parametric. And so I went down the Blender rabbit hole and I felt pretty crappy when I realized like, this is not the tool that I should be using. So I made a video about it, which was sponsored by Onshape, to be fair, but it was also just my opinion of like, hey, don't fall down this rabbit hole unless you want to go down because that wasn't made clear to me. It was like Blender's free. Blender can do everything. Blender is the most powerful. All of those things are true, right? Blender is the single most powerful design software out there probably for all around usability. But if you're doing parametric modeling, I noticed you didn't mention there's a world champion using Blender for parametric design.
Not yet. Who knows that?
Not yet.
Yeah, we had this past month we had our first ever high school edition of the CAD vs. CAD speed modeling tournament. So just for those who are not familiar with what we're talking about, the CAD vs. CAD speed modeling tournament format is such that we take a single 2D drawing and we show it to two users at the same time. And
Right.
then those two users attempt to model up that 3D model, go from a 2D print to a 3D model and calculate the mass of that model. And the first person to calculate it wins. The cool thing is these users are from all over the world. They're using different CAD systems and they're sharing their screen. So we actually get to watch them almost think through the process. You get to see how a Fusion 360 user and a SolidWorks user model the same part at the same time. What types of challenges do they run into? How do they calculate the mass? How do they create ribs? You know, how do they add draft? How do they add cuts? Like, it's really interesting to see kind of these different CAD users modeling the same part at the same time. And
I'm
so,
pulling it up as you speak, by the way, just so you keep
yeah.
talking, but I'm showing people how the system works a little bit.
Yeah, I see this. So, yeah, so I mean, on the website on toby.com, which you have up there in the bars up at the top, there's a section for tournaments. And so if
Mhm.
you go up to that section for tournaments, you'll see kind of this idea of a true world champion and the variety of users that we get. But even down here, I mean, even as you scroll down there, you can see in the community tutorials, there's a lot of variety as
Mhm.
far as the different CAD systems. Like, it's truly a CAD agnostic platform, which I think is really interesting. And it's just so interesting to see the way the users come up with their answers. Like this that you're looking at here, this is
Mhm.
speed run qualification for the tournament. So
Cool.
if you click on one of those video links over on the right, you'll see that what we did was we challenged these users to actually go through and model 3 parts. And the times that are shown there, like the total time, you know, this first user, Great in 808, he's a Fusion 360 user. He modeled these 3 parts up here in just over 3 minutes. So a minute per part. And these are like pretty complicated mechanical engineering style parts. And he was able to do this
Wow.
using Fusion. And so you're able to kind of see like, wow, that's cool. In Fusion, you can create multiple contours. Those of you who are listening, what we're showing here is that he's using Fusion, but he's creating multiple nested contours. And then he's able to select each of
Huh.
those contours individually, like that one he used for a revolve, that one he used for an extrude, that one he used for an extrude to a different depth. And this is all in real time. Like you can see the clock over on the right. That's our clock.
Jesus.
Yeah, and he's able to model this part, and it's accurate. Like these are the dimensions that were on that 2D drawing. There he used a hole tool, and now here he's adding that slot up in the front so that you could put, you know, the inserted component going through the middle, the hinging component going through the middle. Boom, he's done with that part. Now he's moving on to the next part. And for each of these parts, there's a split second where he has to show the mass so that anybody who's watching these videos can actually confirm he did it right. You know, he did it the right
Jesus.
way. And so
This is
Great Nate,
remarkable how fast
it's so
he's
cool, right? And
moving.
so I'll watch speed running on anything. I'll watch somebody speed running a cake. You know, like I think it's so interesting to watch how people speed run and how they kind of come up with these. There's actually, you know, exploits that you could even get into.
Jeez.
Like some CAD systems will remember what the previously input value was in a text box. And so some of the exploits that people will run will be like they'll make one feature with a rib, but a different feature with a thin extrude because they know that the CAD system will remember their previously entered values for those features.
My gosh.
So
And
it's
Vicky says Great Nate was a high school student.
yeah, exactly. And he was
What?
number 1 to qualify into the tournament, but he didn't win the tournament. And that's the other cool thing is that like it's one thing to do the speed running when you're on your own and you can do it over and over and over again, but in the tournament it's a different set of skills. It's like you see the drawing for the very first time. And now
Right.
just like that coffee mug example from earlier, you have to kind of think through how am I going to build this part? Like before you even start in CAD and picking, you know, you have to decide where's the origin going to be? What's my first sketch going to look like? And
Right.
how's that going to have an effect on later parts of the model? Should I center the origin so I can mirror, or should I put the origin in the upper left corner because all the dimensions are coming from there? Like all these
Yeah.
questions happen, and in the tournament, it's amazing how quickly they go from seeing the drawing. And I'm live streaming the drawing to them. So usually what they do is they take a screen capture and they put it over on their second monitor, and then
Yeah.
boom, they're just right into the CAD and they're modeling.
I'm interested to hear if your takeaway is the same as mine. What I have seen from all the content you've created that I've watched is one of the major advantages is how can you eliminate waste, right? Like you see, okay, can I draw this line at this angle rather than defining these two, right? Can I define one thing that's going to then define 3 other things? Or can I do one sketch instead of having to draw and then get it all done at once so I don't have to click sketch, add a new sketch, name the new sketch. It's like how much can you cut the fat so that you do, you know, minimal construction lines, minimal waste, just the absolute essentials. And I realized like I piddle around so much in CAD, like, oh, well, it'll be easier for me if I do this construction line, then I'll have to figure this out and I'll have to do that way. It's like, if you watch this speed run we just saw Nate do, it's like each thing he's doing is being used 2 or 3 times.
Right.
Does that make sense?
And so, and that's a great segue, because it's something I wanted to talk to you about, because it is, you know, what they're doing in the tournament is a skill that gets developed over time. You know, a lot of times what I think of it almost like playing guitar. And it's like, if you learn how to play a scale on guitar, if you just listen to someone else playing that scale, you're gonna kind of piddle around. You're gonna kind of figure out how to do it. But then if you watch an expert do it, you're gonna be like, oh, if I move my hand into this position, I don't have to waste, like to your point, I don't have to waste as much energy, and I can still play the scale, and the scale is still correct and it sounds good, but I'm able to do it more efficiently. And it's really like a quest for efficiency. That's what we're really trying to help people understand. It's not speed, because speed is not, you know, it's one part of the path to mastery. But like, if you ever watch a master electrician, and they go to put a new circuit breaker in your box, they pull out like one tool, like needle nose pliers, and they do all the work with that one tool. And you're like, what? And they get it done in, you know, a minute or two, but they're not sacrificing any quality while they do it. And that's the other piece of the equation. It's not just speed, because if you're just going for speed, you're going to develop bad habits. But if you're going for like true efficiency, then you're not really sacrificing quality, or you shouldn't be sacrificing quality along the way. And that's what I see as like the true path from apprentice to master is, you know, not only developing like your speed, your chops, your hotkeys and everything, but doing it in a way that it's actually going to help you create quality parts to be 3D printed, or quality parts to be manufactured. And so I think that the way that journey can occur, and what we've really spent a lot of time developing on our platform, is through what's called the Practice Models app. And that's the app that you were in a moment ago.
Let me pull it up again.
So what this app is it's a library that can be filtered. It can be totally filtered. So you can filter by the skill level that you feel like you're comfortable at. Tier 1, Tier 2, Tier 3, Tier 4. And each skill level is going to require a few more features to complete the model. It's going to require more knowledge. But you can see here that it says 240101. You click on that. And then if you scroll down, you can see that it says click here to begin.
Yep.
If you scroll down a little further, you can see there's community tutorials. So when you say click here to begin, there's a big button that says reveal drawing. And when you say reveal drawing, boom.
I'll do that.
Do it.
Yep. You're delayed. Your audio is delayed because I think you're watching the live stream. But yeah. Okay. So what's the mass of this part? I mean, this is obviously really, really simple. It's a tier 1 part, but everything you need. And I think what's interesting is when I think I'm doing tier 4s now, and you realize like sometimes you'll leave things out that would be helpful but are not strictly necessary because people need to figure it out. Is that correct? Am I correct in saying that? Like you won't over define the drawing. It's like you can figure this out, the tangent of this, if you just do everything right.
Yeah, well, and so what that comes down to when you get to like tier 4, like you're talking about, what that comes down to is kind of order of creation type of decisions. Like, I'm not going to be able to figure out where this boss is because it's at the top of a drafted rib. And unless I create that drafted rib, I'm not going to know what that distance is to the location of that boss. So therefore, I have to create the drafted rib first, and then I'm going to be able to create that boss. And so you have to learn how to do order of creation in order to, you know, accomplish that task.
You see my eyes just going wide. I'm like, I don't know what a drafted rib or a boss is. I have a lot to learn.
Well, I mean, with 3D printing, it's nice because all the walls can be straight. But, you know, when you're injection molding something, you much like when you create a muffin or a cupcake, you know, the cupcake tin has angles on the wall because the cupcake has to come out of that tin. Well, when you're injection molding something, you have to eject the parts from the mold, and they won't come out if the walls are straight.
Okay, so that's the drafted rib. What's a boss? Oh, you froze, or I froze. Something froze. All right, we're back. There we go.
Yeah. A boss is just when you sketch something and you extrude it. Yeah.
Okay.
So boss is just when you sketch something, you extrude it. A lot of times in plastics design, we have what are called mounting bosses, which is where, you know, the two halves of the assembly come together and the screws from one go into the boss of the other. So Yeah, but usually boss just means a extrude of some sort.
Okay, cool. All right, I feel better now. Thank you.
Yeah, all good.
Let me ask, do you feel that this is a good or the best way to learn CAD, or do you recommend that someone spend time going through tutorials on YouTube, or a lot of these companies offer their own free tutorials, and use this to hone the skill? Like if someone is like myself, still very much, I think we're all still learning, but still very much kind of learning their way around. Is this the way to get better, or is this the way to get more efficient and more advanced?
So I think that we've done a great job of developing this platform to a point where it truly could be an educational experience. Like you
Yeah.
could start at tier 1 with nothing. You could try to model that part, the tier 1 part. You could, there's underneath each challenge, there's a link to a library of video tutorials in different CAD systems. So you could watch a tutorial of somebody else modeling it, and then you could click the try again button and you could try it again. And so that I think is the secret sauce, because I think it's just like practicing a scale on guitar. You don't just practice it once. You know, you
Right.
practice it over and over and over again. And each time you practice it, you learn what's the best way to hit these frets? What's the best way to, should I do a hammer on here? What's the best way to move my pick? And you're not going to get that from just doing it once. And so in the world of 3D CAD and in the world of these practice models, it might be something like, is it better to do this fillet at the sketch level or at the feature level? Very common question, right?
Yeah.
And certainly there are performance ramifications of that. And certainly there are, like when you're working with your coworker, there's a communication element of that too. If we decide as a team that we're always going to make fillets at the feature level, and then I start making fillets at the sketch level, you're not going to be very happy with me as a teammate,
Right.
And so, but there are other decisions like that, to your point of reducing waste. So one hack that I've seen a lot from watching the tournaments and from watching people do the speed runs and record themselves is locating a hole using a rectangle instead of using two explicit dimensions for X and Y. So workflow 1 is you sketch a circle and then you add a dimension horizontally for X and then you add a dimension vertically for Y. Workflow 2 is you begin a rectangle, and then when you go to drop the rectangle and you auto dimension the rectangle, and then you begin a circle and you drop the circle at the corner of that rectangle. Well, most CAD systems can still do a cut using that circle, even if there's a rectangle underneath it. And so this is a really interesting workflow to cut down on time. And it's only, we're only talking about a few seconds here, a few seconds there, but that's the whole point of practice, is that you get to really experiment with these different workflows. Is it better to do this as a single group of lines and then do a thin feature extrude? Or is it better to sketch the first group of lines and then offset the sketch to create the thin wall and then extrude that as a solid? Is it better to do this as sheet metal or to do it as a solid? Is it better to do this as a shell, or is it better to cut through the body? These types of questions can be answered by using that try again function and just tracking your time. You can get an empirical answer, yes, this is better. I beat my previous time. Now, it could be that you beat your previous time just because you're getting better because you keep practicing, you keep doing the same thing as well.
True.
Certainly
True.
it could be skewed a little bit. But
You know what
that's,
might
like,
be cool? I wonder if in the future there's a way, because I really want to get better at assemblies and interactions between parts, and I wonder if that's something that's on your timeline. Like I've done a couple assemblies, but usually I just kind of hack everything together and then print it out and see if it fits, because I'm not so good at like the revolving axis, and there's the pin mate feature, and there's so much happening there. But I think that's harder for you to test how that.
So it is.
Yeah.
Yeah. It is harder for us to test. I mean, what we do right now to validate the answer is we ask you for the mass. So would you mind bringing up that that practice model again, just real quick? So that very first one, that tier 1 model.
Let's pull it up.
Yeah. So you'll see that with that tier 1 model, when you go into that tier 1 model and you go to the input for the answer. So you can see that when you say reveal drawing, and then when you say reveal drawing, you can see it says, what is the mass of this part? Let's say you type in there. So it says, what is the mass of this part in XX grams? So let's say you type in there 99 and you press enter, then you're going to see, it's going to say, this is incorrect and the clock is still running. Like you have to try again. What is the answer? So what if we tried 69 for this one? You know, it's always a good guess. If you don't know what the answer is, try 69. See what ends up happening.
No
What does it
kidding.
say? What do we
It
get?
says,
Is it right?
congratulations. I solved it in 29 seconds.
Wow, that's like a speed running record. So
I know, right?
incorrect if the math is wrong, correct if the math is right. However, if you click the X on that purple screen, I don't know if you submitted already, but if you didn't submit, okay, so if you click the X, you can see that on that drawing, if you imagine that instead of drawing it as like an L shape, if you just drew it as like a big long flat rectangle, and then you filleted off the end of the rectangle, you'd have the same amount of volume.
Right.
So you would have the same mass.
Right.
So you'd be able to get this one correct, even if you created the geometry incorrect. And in the community, we refer to that as the Ivan exploit, because we're only asking for mass. And there's actually quite a few ways that Ivan exploit can come up. Like if you have the same radius on a fillet that's concave and a fillet that's convex, well, the one fillet is kind of canceling out the other fillet.
Right.
So you could just say like, I'm just not going to add that fillet. Save some time. Ivan exploit. So there's a lot of these Ivan exploits that are floating around, and it's become kind of this lore in the community, this idea of Ivan exploits, and are Ivan exploits allowed in this contest, or are they not allowed in that contest? But ultimately, you know, what we're doing is we're trying to help people to calculate mass. And so kind of to your point, it does make it a little bit of a challenge to get into assemblies and how, you know, multiple parts are going to be coming together, and even calculating things like clearance. There are several challenges in there, and there are filters up at the top of the app where you're able to go through and you're able to say, I want to filter for multi-body. I only want to do multi-body, which is basically like doing an assembly. But something that I'm very excited about is that just starting just over the past couple of weeks, we've started adding challenges like this one. So what I'm holding up here on the screen for those of you that are listening is a 3D printed soap dish. And so what you do is you put your bar of soap here on this top platform, and then there's a little fluid drain here on the front. And this is now a challenge. It's a 2-part challenge on the website. So if you go to the website and you go down to the newest challenge, it's at the very bottom. It's this one's totally free for everyone. Some of them are behind a paywall. Some of them are free for everybody. This one's free for everybody. What you're able to do is you're able to create all the geometry for this shelf. This is the first one. So what do you think, Jonathan? What types of features would you use for something like this?
I mean, I would probably do that whole thing in a sketch using the linear repeat. Like I wouldn't use the grid fill or anything like that. And I would do the radius inside the sketch.
Boom. One sketch, one feature, extrude it, and you're done. Right? Boom. Done. Perfect answer. And that would definitely work. Yeah, that would definitely work, and that would definitely get you the correct mass. And then the next challenge, the second challenge in February, is this one here, the tray. This is a little bit more complicated. So this one is, I actually tagged this one as a tier 2, because I think that, you know, it's warranted to maybe sketch one hole and do a pattern. So it's a tier 2, but you could probably do it as a tier 1 as well. And then this one is more like a tier 4 challenge, where you're, you know, the soap, where you've got a lot of features. There's a rib here in the middle. You know, there's a lot more features in this, but there's also clearance designed into this part, because otherwise that shelf isn't going to fit. It's not going to sit in there without that clearance. And so to your question of, you know, helping people with designing parts for 3D printing and designing parts that go together, it's coming. It's definitely coming. Like
I have a feeling. I mean, I hate that right now everyone's answer to everything is AI, but I don't know if you watched the demo for ChatGPT 4 Omni, where it like corrects the kids' homework, and I got to imagine that, I mean, if you're getting to a point where it's much more complicated than just the mass of this part, the mass of that part, but what's the interaction? We're probably getting to a point where you plug into a version of ChatGPT and it corrects for people like a human would.
Yeah, I mean, it's certainly possible that we could get to the point where there could be some type of an app. I mean, if you look at some of the stuff that people have done in Onshape with feature script, you know, with like, for example, the lightning feature, which is a custom tool, like I think it's totally within the realm of possibility that you could draw these two parts together fitting at 1-to-1, and then there could be some type of custom tool that would auto create the clearance for these. It's just, you know, right now what I'm really focused on is teaching the humans how to do it.
Oh no, I'm
Because
saying when I say correct, I'm saying could grade the work, could judge the work.
oh, grade the work. Yeah. That's an interesting topic as well, because the situate like it's a really, really interesting situation that we've created on the Too Tall Toby platform, because it truly is CAD agnostic. And
Right.
so we often have to create allowances or come to some type of a middle ground,
Right.
knowing that there's not going to just be like an auto submit and then like a translator that'll read everything. I mean, we do have users using Blender on the platform. Like we
Right.
do have users, we have plenty of users using plasticity. We have users using Build123D. Shout out to Jern, our Build123D expert. You know, we have users using very, very interesting 3D CAD, and the challenge then becomes like, how do we get them to submit a file? Like some of the CAD Onshape doesn't even use files, so it's like, how
Right.
would they submit a file? And at what point does it lose some of the magic? You know,
Sure.
another element of that is like, if you were to ask for the answer in center of gravity in XYZ, then you would not be able to do the Ivan exploit. You would not be able to
Right.
do the thing where the geometry is wrong. But if you were to ask for the answer in XYZ, one, you'd have to have 3 numbers, which is, you know, that much more room for error. And 2, we would have to tell them where the origin is.
True.
And so
True.
part of the fun is seeing 2 users side by side modeling the same part totally different, starting with a different feature, starting with a different origin, but then ending up like converging and almost ending up at exactly the same spot and seeing their answers coming in within seconds of each other. It's so
That's
cool, and
interesting.
it's so exciting, and like I would hate to sacrifice that to say
Yeah,
like,
yeah.
no, you will put the origin right here,
I
and then
get
you
you.
lose some of that magic.
I get you. Now you had a few years back a revelation, or I guess you changed religions, and you've become more and more. I notice you use in your more recent videos you use Onshape a lot. Tell me about that, because I also love Onshape. Um, and my audience oftentimes does not love that I love Onshape in the comments, but I'm interested in hearing, just given how much of an experience you have with SolidWorks.
Yeah, so you know, like you said, I was SolidWorks guru for a long time, SolidWorks expert, SolidWorks instructor, you know, definitely spent a lot of time on SolidWorks, and it just kind of felt like for the past couple of years, it's not really getting much love, much development. I know that the owners of SolidWorks are trying to develop their own cloud-based platform, and I think
Oh,
that's
okay.
great. But it's not, I'm not seeing the love. You know, if you every year SolidWorks releases what's called a what's new PDF, and you're able to read through and you're able to see all the new features that they've added, and it just feels like it's gotten lighter and lighter over the years. And I don't know, you know, if that's like an indication of what's going to potentially happen in the future. But once I started seeing that happen, I started kind of branching out and exploring other CAD systems. And when I found Onshape, it just felt like modern CAD. You know, like it
Yeah.
feels like a modern solution. And when I say modern, what I mean is that a lot of the things that I have struggled with in SolidWorks just kind of work in Onshape to begin with. You know, so
Okay.
everything from being able to like work closely with the tech support team, work closely on the forums, the community part of it, the communication part of it, the ability to work with other people in collaboration in real time. Like some of the things that Onshape can do, you and I could be working on the same part at the same
Right.
time and adding features to the same feature tree on the same part, which like completely blows my mind that any CAD system can do that.
I
Like
know.
it's incredible that that is even a possibility. But even some of the stuff, like if you're working on a project and I can click on your name and follow you and just see what you're doing, and kind of like, it's almost like I'm looking over your shoulder and just being able to see exactly what you're doing. You know, the ability to undo infinitely, even after the document has been closed, and being able to roll back in time and see the entire history of how that document was made. These things I think are things that I have like struggled with in SolidWorks, and that I wish SolidWorks was better at, especially the collaboration part of things. I wish SolidWorks was better about, you know, having multiple users collaborating. The I don't think this is really necessarily a knock on SolidWorks as much as it is just an observation that when you are based in the Windows file system, you're going to have some limitations when it comes
Right.
to simultaneous read write capabilities. Like it's basically not there. There's not really an option to simultaneously read and write for multiple users. So
Sure.
you know that definitely was a huge part of it. I love the fact that I can jump from computer to computer and all my settings are just there. I know that might
Yeah.
sound like a little thing, but it's like, if you've done that several times with other CAD systems and you lose your settings, that it's not a little thing. Like, it's kind of off-putting. And
What do you
so,
mean by settings? Like it's a SaaS, so what can I change on it settings wise?
so settings wise, what you can change are your keyboard bindings and your S key menu, your shortcut menu in Onshape.
Oh, I
So
didn't
those
know
are
I
the
could
ones.
change the keyboard bindings.
Yeah, the key bindings, and I primarily use the out of the box key bindings in Onshape, but I use the S key menu a lot. So in both SolidWorks and Onshape, and there's some other CAD packages that have it too. When you press the letter S, you get a little menu of your most commonly used tools.
Right.
It's just right there wherever the mouse is. And so customizing that is a huge one. Dark mode, enabling dark mode. Materials library, that would be another
Onshape
one.
has dark mode?
Onshape has dark mode.
Bro.
Yeah,
What?
materials library is another huge one. Like, once you configure your
Yeah.
materials library, any of your workflows, some of those things, like if you're using a data management system, they're going to be server side, so you're not necessarily going to lose them. But it's the same like session. It's like you said, it
Gotcha.
is SaaS, but it's like it's truly cloud based, so it's the same session. So it's kind of like anything you might change in Gmail that sticks when
Yeah,
you
yeah.
go from one device to another. Same idea.
So it just occurred to me that forgot that we need to thank our sponsor, which
Yes,
is PCB
PC.
Way, because someone was mentioning how expensive commercial Onshape is. So I better pay the bills.
Let's
For
go.
those of you who are learning CAD, if you ever want to get your stuff actually created in titanium or CNC anything, or 3D printed on industrial 3D printers, or 3D printed out of titanium, PCBWay has you covered, but they can also make your PCBs for you. They have a whole library of projects. If you don't know how to design your own stuff, you can check out the entire project library of things other people have done. And when you order those parts, the designer of the project earns a commission, which is kind of cool. I use them for all kinds of stuff. I'm going to be ordering a bunch of CNC'd stainless steel stuff pretty soon, which is exciting. So check them out. Link in the description. You save a bunch of money, and it supports the channel. And we're back.
Nice. Like it.
So I that's interesting to me. I thought it was going to be more around like ease of use, efficiency, given that you're the SpeedCAD guy. Which I guess I'm a little disappointed, because I was hoping you'd be like, yeah, it's just better, more efficient. There's, but no, the truth is, as you said, it's not the wand, it's the wizard. But it also, I find it super vindicating, because people have a hard time believing that a cloud-based solution can be as powerful as these heavy apps that have been around for decades, that people run on like gaming rig level computers, but it is fully featured. Is there anything you don't?
Yeah.
Is there anything that Onshape is missing?
When I'll tell you one thing that Onshape is missing. I keep meaning to submit this as an enhancement request, and that's the thing, is they make it so easy to submit enhancement requests. I really have no reason not to. But it's like when you go to do revolve, and you pick the profile that's being revolved, it'd be nice if you could just press tab and it would advance to the axis to revolve. It's like probably wasn't what you expected.
Yeah, that's way over my head. I thought you were gonna be like, this kind of analysis, or like wind tunnel testing, or all these crazy things.
No, I mean, the way you think about a platform like Onshape is that instead of it scaling vertically, like what you're saying about the performance and it being SaaS and not being on like a super high-end machine, instead of it scaling vertically, think of it as scaling horizontally. So it's like, if you're doing something that's really heavy on the current tab, just open a new tab in your web browser and start doing something else on that tab. Like,
Oh, wow.
you have the ability to have all these different tabs open because all the processing is happening on their end. So
That's
just think of
cool.
it that way. Like, you're not locked into your one current tab. You can do lots of different things at the same time, and you can have lots of different tabs open. And so that's kind of that's, I'm not trying to turn this into a commercial for Onshape. This is like, just genuine from my observation. Like, I really think that it's a nice solution. I'm not going to say it's the best solution or the worst solution. It's just something that I've been really happy with so far. And when I find something that I like and that I'm happy with, like, I've learned to just kind of stick around.
Sure.
You don't have to tinker too much.
Well, I think it goes without saying, and I think probably the audience already knows that I feel this way and can assume that you feel this way. But like, if you're into 3D printing, you really need to learn CAD. You can get by for a while printing other people's designs, but you're just going to be so restricted, right? Because there are so many things that are so individualized. Like my specific brand of lock going to my specific brand of bicycle, where there were ones that had my lock and ones that had the same diameter as my bicycle, and putting A to B, and it was like a 5-minute CAD job.
Yeah, I think that's a really important topic to get into because I've noticed that several of the big names in kind of the 3D printing space are making this observation that 3D printers are going through an evolution where they are no longer for the tinkering community
Right.
exclusively. It
Right.
used to be that, my first 3D printer was an old MakerBot Replicator 2.
No
And so
kidding.
yeah, that thing it was a tank and it ran forever, but you had to spend, you're talking like 30, 40, 50 hours tinkering,
Right.
taking the thing apart, putting it back together, taking the thing apart, fixing a clog. Like, how do you fix a clog in a MakerBot Replicator 2? You have to take the whole hot end apart. Like, you have
Right.
to take it off, take it apart, and clear the thing with something, and that's the tinkerer mentality. And a lot of us were fine with that for a long time. But now it's becoming like a plug and play environment where
Right.
you just get a 3D printer and you go to Thingiverse and you download something and print it. And like, you literally take it out of the box. And sometimes the filament is like already there. Like, you just have to go like this, like load it into the feeder, and that's it.
Right.
And you're printing. And so that's a real shift. And I think that because of that, we're going to see that over these next couple of years, there's going to be this huge influx of consumers who are getting their first 3D printer. And so for that group of people, yeah, it's going to be fun to go to Thingiverse and to download items. Where do you get your models from? Do you get them from
I was
there?
gonna say, you must have seen the look on my face. I don't go to Thingiverse. I like printables the most, but
Printables?
if I like need to find, an existing model and I want to make sure that I covered my base, I'm gonna search things.
So you go to a few different spots.
Yeah, but
Yeah.
printables is my home.
Okay, so
Yeah.
printables. So yeah, I mean, I think eventually people are gonna struggle to your point, realizing that like, yeah, I downloaded this cool thing that connects the lock to the bike, but it's loose or it falls off my bike frame or this or
Yeah.
that. And so I think that now more than ever, we're going to need to see a community of or tools to help that community to learn how to go from a napkin sketch to a 3D printable model. Because, that's a skill in and of itself. Like, you have to learn how to get a caliper and go and measure that bike frame and then measure the lock. And then you have to kind of visualize like, well, what do I want this thing to actually look like? And then draw, hand sketch it out maybe, and then start putting it into CAD. And so that's what I'm excited about, moving forward this year. We're definitely going to have more of those. I think, one of the challenges that I'm going to create next is going to just be a hand sketch instead of it being like a nice, fully defined 2D drawing that comes out of CAD. I think I'm just going to hand sketch something up and say, guys, here, model this and see if you can come up with the correct mass from a hand sketch, because I think that's something that people they need to understand that that's what the process is. You look at what your physical geometry is. You measure your desk, you measure the thickness of your desk, and then you
Right.
draw up kind of what a bracket would look like that would fit on that. Then a lot of times you print it and you realize like, it's too tight. Doesn't fit. It breaks. Like, as soon as I put
Yeah.
it on, it pops off. And then you do it again, you go through that iterative process.
I also thought of, for me, I'll admit it's like the efficiency mindset of me. It's really hard for me to model like okay, I'm gonna give you direct feedback. One of the issues that it's not your fault that I have with modeling stuff on Too Tall Toby is it's like running on a treadmill. You know what I mean? And so I volunteer for a local, I don't know how to explain it, but like they give wheelchairs and other accessibility equipment to like elderly and injured and soldiers and stuff like that. And I'll model for them all day long because it's really good practice for me and they give me really hard stuff. But
Right.
it's also, I know like it's going to good use. It's hard for me to like model something that I'm never going to use. So one idea I had for you that I think would be really cool is like submit your sorry, I'm squirming. Submit like something that you need made and then people compete on that why I think it's interesting is as you said, like it's great to get technical drawings, but a lot of time in the real situation, like if I'm modeling something for my mom, she's gonna hold up a ruler and like, so it's like, can we compete on who can figure out what the hell this person actually wants made and
Yeah,
actually
I like that.
realize it and create it and then hopefully help someone who's in need of, some part to fix their mom's what are those things?
Like
Rascal.
a walker.
The
Oh, rascal.
rascal.
Yeah.
Um,
Yeah, I think that's
an
great
idea.
feedback. I mean, I think they kind of where we're going currently, which is kind of like the middle step in that, is trying to release more challenges that can be 3D printed, that can
Oh
be
yeah.
functional. Like the soap dish. Like this is something you could 3D print
Right.
for yourself. You can 3D print it for your family. Most people use soap. Not there's probably somebody in your family who will receive this, and it's more like a
Right.
subtle hint, like, hey, you should start using this.
Right.
But that's one that we released last month. Here's another one that I've got. This is a little case that you can use to hold guitar picks.
Oh,
The
cool.
picture. So a little case here. So it's functional in the sense that like it does kind of latch closed and then it
Yeah.
pops open. So I think that I'm hoping that maybe by releasing more challenges like this, where you can draw it up, but then you can actually 3D print it, it'll
Right.
help people not only stay engaged, but it'll also help them to learn some of those ideas like clearances and having like a bump mechanism, like a friction based
Yeah.
mechanism, and learn how long does that actually last. Like for the guitar case, I've probably opened and closed this 1,000 times and it's still engaging, but will it still do that after 1,000 more? I don't know. It's just a little
That's
bump
so
there in
cool.
the bottom. So yeah, I don't know if that's actually going to keep working or if it's going to stop working eventually. But for now, it works great, and then it locks in and then it doesn't open anymore. So
I
and this
need to
one,
get better at that. That's the exact kind of stuff that I want to get better at.
yeah, and this
I
one
need to
has
get on there.
a little. It's got like a little functional ramp here too, so that when you're playing guitar, you can operate this one-handed. So it's got this little ramp here where you can kind of pull the pick
No
out and
kidding.
slide up the ramp. So there's actually things you can do when you're 3D printing. There's things you can design if you know CAD, and it's not a complicated feature. It's a line
Right.
and another line, two lines. It's not a complicated feature. But when you really learn how to use 3D CAD, even just fundamentally, that's when you can really get the most out of your 3D printer, because that's when you can start making things that are going to be exciting and functional and that actually do help your life, like become more efficient. I
Totally.
think one of my fun facts, I said, like, every problem that I see, I right away think like, how can I solve this with 3D printing?
Oh man, I got a good story for you on that vein. The like when all you have is a hammer, every problem is a nail. Well, I built
Yeah.
this standing desk in the office, and when I'm typing, my second monitor like gyrates,
Mhm.
and my dad came into the office. And my dad's older; he's 83, right? And so a lot of times I'll like dismiss him as like ask not dumb questions, but like, of course I thought of that, Dad. Like I'm the young, sharp, whatever. And so he walks in, he sees me designing this hook to hang my very heavy backpack from it to add some like mass to the table and hopefully ground it.
Okay.
And he looks at it and he's like, "You put in all the screws, right, on the desk?" I'm like, "Yes, Dad, of course I put in all the screws." And he's like, "Do me a favor, like when you go down there to install this hook that you just spent an hour designing, just check that all the screws are in there." I was like, "Dad, come on. What do you think?" Yeah, I was missing 6 screws.
Oh,
So, like,
man.
don't always rush to design a 3D printed part, but yeah, I'm the same way, like to the extreme.
Yeah.
And needless to say, I put in the 6 screws that were supposed to be connecting the legs to each other, and the desk doesn't wobble anymore.
Oh, nice. So that's
Yeah.
great. Have
Yeah,
you
man.
ever drawn something and 3D printed it knowing that it would be so much more efficient to just buy the thing?
Yes. Oh, yeah.
Yeah.
Yeah, yeah.
Yeah.
But
That's
I
fun.
justify it as like in Israel, everything is hard to find. And like I speak the language, but I don't read it as fast as I could. So it's like I'm gonna spend 2 hours. It's just faster to design and print it.
Right.
Um,
Right.
but no, totally,
Yeah.
100%. Or like I 3D printed a stool because filament is cheaper than like my time to go find the right stool that's gonna fit exactly the way I want it. That kind of stuff all the
Nice.
time.
Nice.
Yeah, yeah.
Yeah.
So Guys, by the way, feel free to ask questions. We're going to wrap pretty soon. But if you have
Yeah, I was
any
gonna say,
questions,
I feel like we're neglecting the chat. I feel bad for the chat. Sorry,
n-
chat. We
they're
love you
all
guys.
super thrilled because Bearded Bucket was very generous and bought half the chat memberships. So thank you,
Nice.
Bearded Bucket. That was very kind of you and
Oh,
generous.
that's awesome. Shout out
What
to
would
Bearded.
be, I mean, obviously, I think the advice is go on tootalltoby.com and do a bunch of free challenges. And if you love it, check out the membership, support another content creator who's, I mean, you're doing all these CAD drawings yourself, right? Like you're spending time creating these drawings for people to then go and
Yeah, not only creating the drawings, but just developing that platform to be engaging, interactive community. It's a community type environment. So, the advice, the thing I would ask everybody to try to do is go to tootalltoby.com, sign up for a free account. There's a filter where you can say filter the challenges by free and go through and start doing the free ones. And if you enjoy those free ones, you can do them. You can do them again. You can watch the tutorials that are in there. And if you like this type of a platform and you like this way of learning, maybe, sign up for the premium, support what we're doing over there. That's going to unlock, there's 142 challenges right now in
wow.
there. So you can definitely, the idea is, I mean, there's some people who are very fanatical. If you look at the community scoreboard, you can see that there's some people who have done all 142. I think that's awesome.
Jesus.
And they're from all over the world and they're using all different CAD systems. But the idea is that with that many models, you can kind of filter out by what you need. So if you just need tier 1 and tier 2 to get up to speed to 3D print your designs, do it. Go for it. If you're just interested in sheet metal, just do all the sheet metal challenges. If you're
Yeah.
just interested in like swoopy, lofty stuff, you can filter by that. So whatever it is that you're most interested in, we've added in filters up at the top to help people through that.
Great.
The
Great.
other the other part of this is that on Mondays we live stream on my channel and we do a live version of this challenge. So we show a 2D print to the chat and then we have the chat pros go through there and try to solve that model. So anybody who's in the chat, you don't have to be a
That's
pro.
cool.
Anybody who's in the chat can try to solve that challenge, but it's pretty cool because they're competing against each other and they're trying to figure out what is the mass of this part. And we do that every Monday. Model Monday Live is that live stream.
And my other piece of advice would be I actually find watching the video library, not just yours, by the way. I mean, you solve most of these challenges as well and talk your way through it, but watching how other people do it. And I always used to say, like, when my audience would ask me in my last business, like, whoa, what do you think of Tony Buzan, or what do you think of Anthony Metivier, like other memory experts? And I'd be like, buy their books because I have a way of teaching and that may work for some things, but some of the ways I explain some of the concepts may not mesh with you. And like, I'll watch one of your videos and be like, oh, I don't really get this whole spline thing. And then I'll watch someone who's done a challenge and I'll be like, oh, it just clicked for me. Right. So, and there's no shame in that, right? Like different instructors are going to have different ways of teaching different things. And I think one of the biggest values of your website is like just seeing the replays of how people have solved these challenges. It's like, oh man, and I can make sure that I watch it in Onshape because I don't really care to see how someone did it in SolidWorks. It's not super helpful to me.
Right.
So pick your CAD software and go through and watch those speed runs of people who are using the same software as you, and it'll blow your mind.
Yeah, using the same software, modeling the same parts, and the current project that we're on is the tutorials so that people can submit their own tutorials. But what's coming right on the heels of that is a similar table for speed runs. So when people want to get in there and
Cool.
start speed running and recording themselves doing those actual challenges, like to your point, it's when you see somebody else going through using the same CAD system as you and modeling the same part that you struggled to model, it's just so insightful, and you don't know what you don't know. We had
Totally.
a SolidWorks speedrunner who was using there's a tool called intersect, which is very similar to like a Boolean command in Onshape or Fusion. And he was using it in a very unusual way. He was basically using it to like subtract off parts of the model in a way that I would never have thought to do. And he was doing that while he was speed running. And then all of a sudden, like 3 or 4 of the other speedrunners started using that same technique. So it's really, really valuable to see how other people are doing things. And, you might unlock a feature that obviously, like, we want you to speed run. We want you to be excited about speed running. But the real goal here is for you to get better at your job and get better at 3D
Totally.
CAD.
Totally.
And that
And I still like, there are things that and you'll remember, like one of the things about memory is it's location based, right? So like if I remember which of your videos I was watching when I learned about move face, and you're really good about pointing out, and you're like, oh, I would not have done move face in that way. Like I usually think of move face as fixing something when the spec changes, and I still use it in that way, that innovative way that someone used it. It's like super valuable and faster.
right,
And most importantly, it's
right.
faster.
Yeah,
Um,
you learn something. Well, I remember I once went to a tech conference and a guy was presenting about flow simulation, and he
mhm.
did an extrusion. He sketched something and extruded it, and then he did a right. This was in SolidWorks. He did a right click and then did like up to next for an end condition. And I was like, "What? There's a whole right click menu there?" Like, and
Yeah.
it had nothing to do with his presentation, but just the fact that you're watching somebody live demo, you can learn so many cool shortcuts, and that's what we've really set out to do on the platform.
Oh man, the up to next and like starting offset from next, that was like mind blowing for
Yeah,
me. Because
huge.
also then now if everything changes down the line, you discover the sizes aren't right, all these blind extrudes become useless, right?
Right. You just have spaghetti.
Um, I think it's really, really cool what you're doing. I love it. Like I said, I aspire to do a whole lot more of these speed runs. I should be doing that in the evening instead of doing more work. I should take some time and really focus on this. Guys, make sure to check out the links in the description and support Toby and what he's doing. Toby, thanks for coming on. I do need to ask one thing that I don't know if it's like a mystery in the lore of Too Tall Toby, but how tall is too tall, Toby?
Yeah, definitely tall. Yeah, that is a good question. Tall
That's
enough
it.
that, like, I hit my head on stuff, and, yeah.
All
Yeah,
right.
good
Okay.
question. Thank you.
All right. We'll keep it a secret. Toby, thanks for coming on the show. I really appreciate you, my friend.
Awesome. Thank you so much for having me. Take care.
All
See
right.
you,
I'll
everybody.
take us out.
Thanks for tuning in to the Infill Podcast. For show notes or links to anything mentioned in today's episode, visit thenextlayer.com. If you enjoyed the episode, please don't forget to leave us a review wherever you're listening, or click the like button to let us know. And consider subscribing to The Next Layer on YouTube so you can tune in live and participate in the next conversation. We'll see you on the next layer.